So here we will begin with a walkthrough of the odd numbers from the Unit 3 Honors Review Packet. So number 1, I want to use the cube at the right and list all of the possible responses that we have. And I'm looking for segments parallel to EH. So any segment parallel to this one right here. Well, right off the bat, segment AD, we see that that is in the same plane and will never intersect. So segment AD. In the back here, segment FG is also a parallel segment to EH. And then this one is a little bit harder to see, but segment BC is also a parallel segment to EH. It doesn't quite look like it's in the same plane in the picture, but I could put a plane that goes through both of those segments and those segments still never intersect. So the definition of a parallel segment or line is a line or segment that is in the same plane and will never intersect. So BC is included. It is parallel to EH. Okay, number 3, all segments parallel to CG. So let's do this one in another color so we can kind of differentiate between the two. So looking at CG, all of the segments parallel to CG. Right off the bat, we see that segment DH is parallel and segment BF is parallel. And just like with number 1, we have a segment that does not quite look like it's parallel, but if I put a plane through it, I could see that they are coplanar, and this one is segment AE. Okay, numbers 5 through 9 are using this picture here at the right. So number 5 says, well, first of all, we want to use this diagram to name the relevant transversal, and if there is none, just simply we want to write no transversal. Angle 2 and angle 4. Which line touches both of these angles? That is the relevant transversal. So 2 and 4, line B touches both of those lines. So I would say that line B is my relevant transversal, and naming it is important. If you don't put the part naming line, it's not completely correct, because naming, as we learned at the very first day of school, and we've been reviewing and refreshing every single day pretty much, we have to name these geometric pieces appropriately. Number 7, we have angle 4 and angle 6. Angle 4 and angle 6, there is not a single transversal that touches both of these lines. So for 7, I would say no transversal. Number 9 says angle 5 and angle 1. Here's angle 5 and here's angle 1. Line A touches both of those angles. So my relevant transversal for number 9 is line A. Okay, number 11, 13, and 15 are going to be still dealing with this image up here. So slide this up. I want to classify the angles as vertical, linear pair, same side interior, same side exterior, corresponding alternate interior, alternate exterior, or none of the above. So pretty much I just want to identify the angle relationship. So number 11 has angle 6 and angle 5. Angle 6 and angle 5, these are on the same side of their relevant transversal, and they're on the inside of my two coplanar lines. So number 11 would be same side interior. Okay, number 13. Angle 3 and angle 8. These are on the opposite or alternate sides of the transversal, and still they're on the inside, the interior of my coplanar lines. So these would be alternate interior angles. And then number 15, I have angle 4 and angle 10. Angle 4 and angle 10, these form a linear pair. Okay, moving on, we're still using the image above, so it shouldn't say in the diagram in number 4, it's really still the diagram just from above. We're adding information on, and we're saying that A and B are parallel, and that M and N are also parallel. This helps us out because now we know that our angle relationships have rules that we can follow. So the congruent and supplementary, these hold true. So what I want to fill in here is either congruent or supplementary, and then because of which theorem or postulate. So number 17 says angle 5 and angle 12 are 5 and 12, well, we know these are congruent because we know they're congruent because they're vertical angles by the vertical angles theorem. We know they're congruent because of the vertical angles theorem. Okay, and next we want to do angle 9 and angle 10. Angle 9 and angle 10, these are a linear pair, and we know linear pairs are supplementary. So angle 9 and angle 10 are supplementary because of the linear pair postulate. So the linear pair postulate. Okay, that's the first page. So moving on to the second page. Now we're on number 21. 21 through 26, that whole page, is asking first to identify the angle relationship name, to then set up an equation, and then to solve for x. So for 21, we see that these two angles, these are alternate exterior angles. So I have alternate exterior. That's my angle relationship. I know that alternate exterior angles are supposed to be congruent, so I'll make a little note for myself here. I want to create an equation that represents congruence. So I just have to set these two equations equal to each other. So 14x minus 1 equals 12x plus 17. If I subtract 12x from both sides, I have 2x. If I add 1 to both sides, I have 18. Divide both sides by 2, I have x equals 9. All right. The next problem is a little bit it's a little bit harder to see. It's a little bit something we haven't seen before. I want to visualize this in another way. I want to see, well, I have to solve for x here, and I don't really know about any angle relationships, so that's why it's not listed as a possibility to fill in. I'm going to extend this line with a dotted line and do the same here for this one. Well, I know that this angle up here and this missing space is the alternate interior angle with angle 31. So if I were to kind of visualize this as a line that just keeps going, same for this. This space right here is the alternate interior angle for angle 31. And my lines are parallel, so I know that these are congruent. So I can fill in 31 degrees for this piece right here. And then I can do the same thing for this angle down here. I know that it's the alternate interior angle with the angle that's 36 degrees. So this one is also 36 degrees. And then I know that this angle measure here, well, the sum of the interior angles of a triangle are supposed to be 180 degrees. So 180 minus 36 minus 31 leaves me with 113. So 113. And then I know that this makes a linear pair. So we're getting kind of complex here. So let's write out all of our steps that we've done so far. I have identified the angle relationships, filled in the missing angle measures, and then I found the 113 by subtracting 36 and 31 from 180. And then I know that the angle x, the one that we're looking for, and the one that measures 113 form a linear pair. So I know that the measure of angle x plus that 113 that we have equals 180. So I can find the measure of angle x by subtracting 113 from 180. I'm left with 67 degrees. So really, solving for x equals 67. This is a little bit complicated. But if you can visualize it and see the different angle relationships we have, and knowing that the sum of the interior angles of a triangle are 180, you should be able to go through and find the value for x. Okay, 25. 25 is asking for a little bit more. It's asking for you to solve for x, y, and z. So first, I think it would be easiest to solve for y. Solving for y, because we have a linear pair right here. So I know that 2y plus 8 plus 142 equals 180. And this is because these are a linear pair. So, combining my like terms, I have 2y plus 150 equals 180. And 2y equals 180 minus 150. So this is 30. Divide both sides by 2. I'm left with y equals 15. And so knowing that this is 15, I can do one of two things. I can either plug 15 into my y here and then solve this knowing that these are same side interior angles and that they should be supplementary. So I could plug 15 in and then say this piece plus this piece equals 180. Or I could recognize that 4x plus 6 and 142 degrees, those are corresponding angles. And if these lines are parallel, I know that they should be congruent. So 4x plus 6 equals 142. And then I would have 4x equals, and then I would have 142 minus 6, and that gets me 136. And then divide both sides by 4, I'm left with x equals 34. And then lastly, I want to solve for z. Well, I can identify that z and the angle that measures 142 degrees, these are alternate exterior angles, and I know that this line is parallel to this line. In fact, all three lines are parallel, so I know that they're supposed to be congruent. So z, this is probably the easiest one, is 142 degrees. Okay, let's move on now to the next page. The next page, so let's start with 27. I want to find the value of x that makes j parallel to k and name which theorem or postulate we use to prove it. So I have these two angles are corresponding. And for corresponding angles on these lines, for these lines to be parallel, my corresponding angles need to be congruent. So I just want to set up an equation that makes these congruent. 5x plus 7 equals x plus 43, all for x. So subtract x from both sides, I have a 4x. Subtract 7 from both sides, I have 4x equals 36. Divide both sides by 4, I have x equals 9. So when x equals 9, I have corresponding angles that are congruent. So when proving parallel, we always want to use the converse of a postulate or theorem. So the converse of the corresponding angles postulate. Okay, number 29. Number 29, I have alternate interior angles, and I know alternate interior angles are supposed to be congruent. So again, I want to set up an equation where I set them equal to each other. 3x minus 5 equals 21x plus 5. Subtract both sides by 21x, I'm left with 2x. Add 5 to both sides, I'm left with 2x equals 10. Divide both sides by 2, I have x equals 5. So when x equals 5, I have congruent alternate interior angles. And so the theorem or postulate that I used, again, whenever we're proving parallel, we have to use the converse. So we're using the converse of alternate interior angles theorem. Alright, number 31. I'm asking if lines P and Q are parallel and to have you indicate why or why not by giving the converse of the appropriate postulate or theorem. So I have same side interior angles here, and I know with same side interior angles, I want my angles to be supplementary. 130 plus 50 is 180, therefore yes, they are supplementary, so yes, P and Q are parallel. And I've used the converse of same side interior angles theorem to prove that these lines are parallel. 33, I have alternate interior angles, and for my lines to be parallel, I would want these to be congruent. They are in fact congruent, therefore I have congruent alternate interior angles. So yes, my lines P and Q are parallel by the converse of alternate interior angles theorem. 35, I have alternate exterior angles. For my lines P and Q to be parallel, I would want them to be congruent, and X and X, those are both the same variable, same value. So yes, they are congruent. So yes, these lines are parallel by the converse of alternate exterior angles theorem. All right, let's move on to the next page. For the next page, we have number 37. 37, I want you to find the value, so I want you to actually use the image to determine which lines, if any, are parallel. So use the image to determine which lines, if any, are parallel. So I'm telling you that 2 and 4 are congruent. Angle 2 is congruent to angle 4. And these are on the relevant transversal, which is line M, and they're affecting lines A and B. So 2 and 4 are corresponding angles, and I'm saying that they're congruent. So if I have congruent corresponding angles, I know that A is parallel to B by the converse of corresponding angles postulate. Okay, 39 says that angle 2 is congruent to angle 11. These are alternate exterior angles. I want my alternate exterior angles to be congruent for my lines to be parallel. And they are in fact congruent. So I know that M is parallel to L by the converse of my alternate exterior angles theorem. Alright, 41. The measure of angle 7 is 50 and the measure of angle 8 is 130. Well, 7 and 8 are a linear pair. And linear pairs are supposed to be supplementary, and in fact 50 plus 130 is 180. But this does not give us any information that helps us determine any of these other lines to be parallel. So I'm going to say we have not enough info. All right. So 43 I will go over in class. 43 is a little bit, the way it's written here is a little bit complex. So let's move on to the next page. This is the topic 9 review. And I want to find the slope of each segment in the graph. So finding the slope of each one. So 45, the slope of AB, let's do rise over run. So starting on the left, we're going down -3, and we're going over 3. So down 3 over 3, my slope is -1. That should be -3 over 3. 47, the slope of EF. Again, starting on the left, we go down 3 and to the right 3. So again, my slope is -1. 49, are any of the lines parallel? Well, we can answer that because we do see that these two have the same slope. So I would say that segment AB is parallel to segment EF. And I'll give you guys a hint. These two are not going to be parallel to the other two. And I'll say yes, they're parallel. My justification is they have the same slope. Okay, number 51. Determine if each pair of lines is parallel, perpendicular, oblique, or coinciding. So oblique is just another way to say intersecting. So number 51, we have what we notice. Oh, well, we've got the same slope here, different y-intercepts. This is parallel. My justification would be same slopes and different y-intercepts. 53, oh look, I have to solve this one first for y and this one so I can identify the correct slope. So here, if I solve this one for y, I would have y equals -x plus 4, and this one would be